Hi guys! For coaxial 110 GHz VNA solutions, in addition to the regular system architecture of VNA plus test set controller plus extension modules, Ceyear can also provide the world's first all-in-one coaxial 110 GHz VNA. This is a coaxial wideband 110 GHz VNA in a single regular size structure. It features compact size, 15.6-inch capacitive touchscreen. Only a few physical keys are left on the front panel. It can be 2 or 4 ports configuration. Here are the 1.0mm connectors. The front and rear handle design makes it easier for 2 people to carry and move the VNA. There are so many different connectors in rear panel for different options and test purposes. All these interfaces make the system integration and function extension easier, with high efficiency and flexibility. Today, I will use this VNA to test a fixed attenuator, a DC block, direction coupler, cable, and a balun. We connect the high-performance 1.0mm cables to the ports. After full warm-up, we use this calibration kit to make the calibration. Firstly, we set the start and stop frequency to 10 MHz and 110 GHz. The sweeping point is set to 1001. Press menu cal, select guide cal, and then select the proper cal kit model. Then press next to enter the calibration screen. We use the toggle range to fasten each one and press corresponding button. At last, we connect the 2 cables together and make the through calibration. We press finish to save the calibration data. We connect the fixed attenuator to the testing ports. We can see the VSWR is less than 1.36 and the attenuation at 110 GHz is about 7.2 dB. We connect a DC block to the port. The VSWR is about 1.6 and the maximum attenuation is about 2.4 dB at 75 GHz. This coupler is used inside of this VNA. We connect the directional coupler's input and coupling output to the test port. The through port is ended with a load. We can see the maximum input VSWR is 1.68 and the coupling is about 12 to 13 dB. Then we connect the through port to VNA's port 2 and enter the coupling port with a load. You can see the VSWR is about 1.6 and the insertion loss is about 2.4 dB at 110 GHz. Now let's test a 60 cm 1.0mm cable. We can see the VSWR is less than 1.4 and the attenuation at 110 GHz is about 8 dB. We know balun, short for balanced to unbalanced, is a device to convert a balanced signal to an unbalanced one. Let's confirm the phase difference of 180 degrees. We connect the common and 0 degree port to the VNA. A load is connected to the 180 degree port. We can see the insertion loss is less than 11 dB over the full band. The VSWR of common port is less than 1.5 and the VSWR of the 0 degree port is 2.25. We change the S12 to phase display and change the scale to 5 degrees per division. We double-click the title bar to display the phase window in large screen. To check the phase difference easier, we press Analysis menu and enter the Offset Slope dialog. Set the phase offset to 180. We also normalize the data trace. Now we connect VNA's port 2 to the 180 degree port and enter the 0 degree port with a load. We can see from the screen that the phase balance is less than plus minus 6.2 degree.